So in this video, we are going to use R and RStudio to forecast Winter's method, which captures a level, a trend, and seasonality. To do so, we're going to use some files. So first of all, we're going to use newyorkbirths.csv as well as the forecast kings example.r. As best practices, it's always good to kind of understand what data you're reading in. So if you open up the file newyorkbirths.csv, mine opened up in an Excel or maybe yours opened up in a notepad, and you can notice there's no header here. It just has 23.179. If I keep going down, there's something here. So there's 96 pieces of data, and so we want to make sure we're reading all of that in, okay? So let's now open R and the file wherever you saved your forecast kings example.r. And we're going to get started. I'm going to go until where the file location is, and I'm going to run that. Okay, so now I have that file location. Again, if you want, you can run all this other stuff, but I'm going to jump down to where it talks about this New York births data set. So I'm basically going to, by running this line of code, it says, okay, go find that file location, which I said above. Go find this file, newyorkbirths.csv. It's a CSV file, and there's no skipping stuff. Okay, so then I'm gonna run that. And now I have that, and let's make sure it actually is capturing what I want. So there's 96 pieces of data. That's a good sign. Starts with this, it just gives it a random, title. Okay, cool. So again, we're going to use time series forecasting methods. And so we need to make our data set a time series. One thing to note is this data is actual number of births per month in New York City from 1952 to December 59. And so even though, we could just start at 1, I'm going to actually give it a start date of 1952. So that's what the start part does. It's not required, but by having it, you can see we now have an x-axis. If I plot that doesn't start at 1, and instead it starts at 1952. Okay. And so now we have this data. It might not be super obvious, but there is actually, it does look like to be like some repeatable pattern. So it looks like, okay, something happens, there's a peak, it goes down, there's another peak, it goes down, there's a peak, it goes down, right? So it does seem to be kind of zigzagging and repeating over time. This actually does have some frequency of 12. How do we capture that? It's good to look peak to peak or valley to valley and count that. So let's just start over here. This would be the peak. So I'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be one set of data. Okay. So then this peak starts again at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here, okay, we're not at the top, but you could say, okay, that still seems, and then it seems to be, this is still a pretty good peak. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then this one's at 1, which seems to kind of repeat. Okay, so that's the frequency is 12. And so for us to actually use winters, which captures a seasonality, we have to explicitly set that. And so what we're going to do is by actually just rewriting over the top is we need to set the frequency of 12. So what I'm going to do here, nothing will change in terms of what happens if I again, plot this. So if I do that, nothing is going to change here. I'm just going to put this and run that. But what it does, it is needed for the next line of code, which is Holtz winter. So again, this is the function we've been using for the other time series forecasting. It's really powerful. But let's again just look at that. So if I go and get the information about that, and you can see over here, okay, so a couple things that is important that we're gonna actually use is the seasonal. So if you have watched the videos about more the theoretical aspects of doing the winters model, we are using a multiplicative model. So it is really important that we have seasonal equal multiplicative. If you don't have this line, you'll get a different forecast because you're actually implementing a different methodology. You're implementing an additive one. And multiplicative is not the default. So you do need to make sure you have this. And then you can see here, because we've turned off, we don't have any of them off, then what we have is the seasonal ones. Okay, so the other thing to note is we don't have alpha, beta, or gamma turned off. They're all on, which we need. And so if I run this one line of code does a lot of really powerful things. Okay, so now all of a sudden we have up here, if I just run, we can also see what gets plotted out. In that one line of code, what do we have? We have the optimal alpha, beta, and gamma. So we've now set our parameters. And we set them, the best value for alpha, beta, and gamma are given here. So we now have our forecast set up. We can also plot that. And what you can see what's happening is the red line is our one step ahead forecast. That's what's captured in fitted, and we'll go expose kind of what's going on there. And then when I change alpha, beta, and gamma, that changes the red line. It changes our forecast. And what we're trying to do is minimize the red and the black, the squared difference between those. Another thing to note, I don't know if you can see this, is that we don't start right away. The reason we don't start right away is we need a lot of initialization. In fact, we have to have an S1, S2, all the way through S12. We need initialization for that. And so you can see we aren't able to start forecasting until later, until over here. But then we have a forecast all the way until the end period. Okay, and we can see that more specifically if we run the fitted. And so by running the fitted, this is the one step ahead. You can see we don't actually start making a forecast until 1 year ahead. So 1953, even though our data has data from the whole year of 1952. The other thing that happens because of our seasonality of 12, R just says, okay, because of 12, we assume it's months. So one thing to note, and this will be potentially a problem on your homework, if you set frequencies of like different things, they mess up with your x-axis. And so just be aware of that. This made the assumption by definition of frequency of 12, it just made it January through February and all this stuff. I didn't change anything. So just be associated with that. So this is in some ways 1 period, 2 periods, 3 periods. They've documented it as months. So that's what's happening in the fitted. We could also see, if we want to print out what is our actual optimal alpha, beta, and gamma. And then SSE, you can see we do pretty well here. So the sum of squared errors, we can do a pretty good job of predicting births. We're not that far off, which is somewhat interesting. And so now we have done the step 3 of our time series forecasting steps, which is creating the forecast. So we have a value for alpha, beta, and gamma. Again, this all happens with one simple line of code. The 2 things you have to do extra for winters is you have to make sure your time series tells me the frequency. And you have to make sure that you use seasonal multiplicative to get the right answer. Just to give you a little bit of more intuition of what's going on, if you have a frequency, you can use this decompose function. And so what I'm going to do is I'm going to run it, and then I'm also going to plot it. Okay, so what is this doing? This gives you a little bit more intuition of kind of what's happening behind the scenes. And so you can see the observed is just the data we read in. So that's the data in our file, New York births.csv. And what we're doing is we're deseasonalizing. So you can see these are the S1, S2, S3, the 12, and they're all the same because we're just setting one over this. So I basically take this and deseasonalize it. And then I also incorporate the trend, the fact that this is going up over time. There are more births over time in this period. But you can see there's some errors happening. And if you see what's going on here, this one's less, the negative than expected and stuff. And so it's not perfect. Again, all forecasts are wrong. That's kind of the residual of capturing seasonality and trend. What did we miss, right? And again, so what we're doing in terms of the Winters-Holtz forecasting method is we are combining these different components in again, the one model we're using in this class is multiplicative way to get a forecast. Okay? And so the other thing is we were given the SSE, but we weren't actually, maybe we want the MSE. And so we might want to understand more about that. And so what I'm going to do here is I'm just going to understand getting the very first thing of the fitted. So if I go look at the fitted, this prints out all of this stuff, which is X hat is basically my one step ahead forecast, but it also gives me the level, trend, and seasonal aspects, which are useful. You can see if you take your birthday month, I'm born in February. February is less than the average because it's 0.91. So in February, if things continue past the 1950s, February is a lower than average month to be born. So if you go find your birthday, and if the seasonal factor has birthday month, if the seasonal factor is bigger than 1, that means your birthday month is more popular on average. If it's smaller than 1, it means it's less popular on average. So you can kind of get that from the seasonality. The trend being positive means more and more people were being born, at least in this period of time in New York City. So the growth was positive. We really only want for MSE the first column. So I'm going to run this, and this will just give me the first column of data. So then here you can see this is just my first column of the fitted. This is basically my forecast. I am forecasting the past. We have data on this. So why do I forecast the past? Because I want to calculate an error measure. And why do I want to calculate an error measure? Is I need an error measure to set alpha, beta, and gamma. And in fact, I set alpha, beta, and gamma by minimizing MSE or SSE, their equivalent approaches. And so what is the length of this? We can just print this out, and you can see the length is 84. In other words, we basically have 1, 2, 3, 4, 5, 6, 7 times 12 months. So I have 84 pieces of data. Realize we had way more in the observed. The reason we don't have as many is, again, we had to initialize, which is why you can see the red line, which is what, if I plotted this, this would give me the red line. I don't start until 1953. So even though I have data from 1952, I don't start until 1953. All right, so to get the MSE, then it's just the SSE divided by 84, and that gives me an MSE that is actually really great. So 0.53. The one thing to note is our data, when I go look at our actual data, it's in, I think these are maybe thousands of births. And so this looks like a really small number, but remember that technically if this, we need to multiply by 1,000 squared to get this, if it's per births information. Okay, so all of that to say, we have not forecasted the future at all. We've only spent time forecasting the past. The reason we forecast the past is we need to set alpha, beta, and gamma. We have those now. So this is creating the forecast. We know that, alpha, beta, and gamma. And so now let's go actually use it to forecast the future. And so again, we're going to use this forecast. And we're basically just going to implement whatever we called our Holt-Winter function, which was New York births winters. And I'm going to forecast 12 on a whole year in advance. And I'm just going to run that. Okay, so when I do that, you can see this blue line is my forecast. So that's actually what's happening in the future. You can also see that it jumps up and down. You can see that information here as well. So you can identify that this is a seasonal forecast because it goes 27, 26, 29, 27, 29, 28. It's not always going up, going down, or staying the same. That means we're capturing the seasonality aspects of it. Similarly, we have a confidence interval. The first law of forecast is that all forecasts are wrong. So we have an estimate, but then we also have kind of a range around it. If we want to be more like a 95% sure, we have to give you a bigger range to do that. And you can see as you go further out, I don't know if you can see this, but these ranges get bigger because we're less and less confident about that. So now you've implemented to forecast this into the future. What if that was 1 year? What if we wanted to make 24? I can run this and you can see what's going on is I have a pretty good forecast. I'm pretty confident about this. As I go in the future, these aren't exactly the same because there's trend There's different values here, but the idea is I really don't know in the second period. I mean, I'm not very confident about that, right? And so I'm pretty confident next year, but what will happen next is less confident.